neural centers back up here in these palatine lymph nodes that are going. I'm probably producing some MHC1. I'm probably producing some, what kind of T cells? What kind of T cells? Cytotoxic T cells. I'm probably producing some cytotoxic T cells to get rid of those viral particles up there. Yeah, all that. That's going on right now. It's CD8 is involved, or no, CD8 interacts with MHC1 molecules. Those are generally only cytotoxic.
Thanks for getting us back on track, Richard.
You can always find an exception.
Thanks for getting us back on track, Richard.
Always find an exception. Okay. Viral protection. You get interferons inhibiting viral replication. It can be an autocrine response. It can be a paracrine response. It gets the NK cells going. NK cells, they sort of carpet bomb. They blow everything out. It's not too specific. They kick out those granulozymes, lyse the cells. But it's better to lyse all the cells in the area than miss the ones that are infected. Here we are, two branches again. Here's our antibody molecule. Our antibody molecule is the B cell receptor. It's got a little tail when it's a receptor. You got your T cell receptor there. I'm going to go back and hit this. The antibody molecule binds things specifically, very tightly. The T cell receptor is a little more loosey-goosey. It doesn't have the high specificity that the B cell binding does. It's still specific, but it's a little less specific. Here we talked about this a second ago. Macrophages, dendritic cells, picking up antigen, going to the lymph node, doing a dance, getting tickled. While it's going down there, the dendritic cell internalizes the antigen, chews it up, pushes it out to the surface on the MHC molecule. MHC1 molecules, most cells within the body. The only place you're not going to find them is on red blood cells. MHC2 molecules, only on antigen-presenting cells. B cells, macrophages, and dendritic cells. T cells are either CD4, CD8. Now, obviously, as you talk with Dr. Newman, you know that T cells go through a process, whether they're double negative, double positive, all that stuff. I'm talking about mature T cells. Bless her. You guys got any questions? Just yell out. Here's the cell, and you know, on this one here, where it has APC, antigen presenting cell, at the top on the left, where it has APC with MHC1 on it. That APC there really should say target cell, not an antigen presenting cell. It should say target cell, because when you have MHC1 out there, it's really not antigen presentation, it's a viral infection. Okay? What can antibody do? It can neutralize toxins, take part in opsonization. As the antibody response goes along, it switches from IgM to IgG or IgE or Ig something. And as it goes along, its affinity for its antigen increases. It binds tighter. we have all this lovely genomic structure with the lambda light chains. You got the V's and the J's and sort of different. You got the C locus in there multiple times. The K, the kappa chain, has the V and the J and the C, and then here's the heavy chain with the VDJ, etc. And they recombine. And they undergo that through that process of somatic recombination, then we get somatic hypermutation, etc., etc. You need to know that. The difference between IgM and IgD is differential RNA splicing. The only place you really see IgD is on the surface of mature, naive B cells. Okay? Hasn't been tickled, hasn't found its antigen yet, but it's mature, ready to go. It's looking for its antigen. That's the only place you find IgD. IgM, secretory IgM, is produced by differential RNA splicing. Here, the summary of this, which is irreversible, which is reversible, the timetable that it goes through, nice order right there. Oops. You must have the appropriate MHC molecule with the TCR, T-cell receptor. Got to have it all together. And right there is a perfect example of what I was talking about, where it's target cell as opposed to antigen presenting cell. That is much clearer. MHC restriction, got that right there. We haven't talked about that yet, haven't talked about that yet, haven't talked about that yet, haven't talked about that. Here's the response. Immunological memory, second response. Haven't talked about that yet. Here is a summary of the timetable of various immune response, innate immunity, 0 to 4 hours. Induced response, that's where you start the recruitment of cells. It goes up to 96 hours. After that, you get the adaptive response going. Protective immunity, that's when you've already seen that antigen. You have memory cells. You can induce those memory cells, get removal of the agent. Boy.